Hey class, in today's lesson we're going to talk about exponential and logarithmic equations, which is found in section 7-5, part 2 of your book. We are going to solve logarithmic equations. Alright, so going back to example 4, it says, wood is a sustainable, renewable, natural resource when you manage forests properly. Your lumber company has 1.2 million trees. You plan to harvest 7% of the trees each year. How many years will it take to harvest half of the trees? Alright, so in order to figure this out, we're going to go back to using our exponential equation. So that's going to be y equals a times b to the x power. Okay, so let's start. A, remember, is your y-intercept or your initial amount, and we're talking about trees as the output. So the initial amount is 1.2 million. Remember, b is the same thing as 1 plus r. So we're going to say 1 plus our rate. Our rate is 7%. And if we plan to take 7% every year, that's really minus 0.07. And the goal is to say, if you plan how many years will it take to harvest half of the trees, and half of the trees, because that's our goal output, would be 600,000. All right, so we need to go ahead and simplify this. It's going to be 600,000 equal to 1.2 million times 0.93 to the x power. Okay. Keep going. The next thing we need to do is, if we want to get x by itself, we need to divide by the 1.2 million. Because in other words, we're trying to get everything away from the x. And by the way, if I haven't mentioned it, x is actually going to represent our years, which we know normally sometimes we switch that out for t for time. Okay, so that'll go away, and we are then left with 0.5, because 600,000 divided by 1.2 million is half, so 0.5 equals 0.93 to the x power. All right, and then the only way to kind of get this x power to come down is to raise each side by log. So this is going to be, I'm going to go back over to the other side. This is going to be log of 0.5 equal to log of 0.93 to the x power. All right, that x is then going to move to the front, so this becomes log of 0.5 equal to x log of 0.93. Then, of course, to get x by itself, I'm going to divide both sides by log of 0.93. All right, so then to solve in our calculators, you would just say log of 0.5 divided by log of 0.93, and you should get, oops, not log, sorry. You should get an x equal to, and I shouldn't say equal, I should say about. X is going to be about 9.55 years. Okay. And again, this all started from our exponential function equation. All right, so let's try this again on the next one. So then it asks, how many years will it take to harvest half of the trees if you harvest 5% instead of 7%? So in this case, all we're doing is changing the percent. So again, y, and I need to change to white. Y equals a times b to the x is the same thing as a times 1 plus r, and I'll say to the t this time, just so it makes a little bit more sense. All right, so again, a is still, or y, because it's half, right, it's still 600,000 equal to a, which is our 1.2 million. If r is equal to 0.05, specifically negative 0.05, and we're adding that to 1, then that becomes 0.95 as our rate. Okay, we need to divide again by 1.2 million. That's going to give us half. All right, and then we need to raise each side to log. So log of 0.5 equal to log of 0.95 to the t. Okay, t then needs to move to the front. So this then becomes log of 0.5 equal to t log of 0.95. Lastly, we're going to divide by log of 0.95. So t will be about, let's go ahead and find that, log of 0.5 divided by log of 0.95 is going to be about 13.51 years. All right, let's keep going. All right, so some vocabulary. It says a logarithmic equation is an equation that includes one or more logarithms involving a variable. So in example 5, it says, what is the solution of the equation below? So we have log of 4x minus 3 equal to 2. Remember that this is the same thing as log base 10 of 4x minus 3 equal to 2. Okay, so what we need to do, honestly, is just rewrite it in exponential form, because that'll help us solve this x. So this is 10, right, because this is log is bay. So 10 to the second equals 4x minus 3. That's going to give you 100 equal to 4x minus 3. Add 3. You'll get 103 equal to 4x. Divide by 4. And then x will equal 25.75. All right, let's go ahead and do the try. Again, really this is log base 10 because we don't see a base, so it must be 10 of 3 minus 2x equal to negative 1. So this really becomes, if log is bay, that's base, the exponent is negative 1, and the answer is 3 minus 2x. By the way, 10 to the negative 1 is the same thing as 1/10, which is the same thing as 0.1. So 0.1 is going to be equal to 3 minus 2x. If I subtract 3, and I throw that in my calculator, 0.1 minus 3 is going to be negative 2.9 equal to negative 2x. We're then going to divide by negative 2. So finally, x will equal 1.45. All right, let's look at our last example. All right, it says, what is the solution of the equation below? All right, so in this case, we're kind of going back to our log properties. Remember, when you see addition, it really means multiplication. Okay, they both have a common base of 10, right? So this is really log of x minus 3 times x equal to 1. Multiply x times x minus 3 by distributing the x to both, and this becomes log of x squared minus 3x equal to 1. Again, remember I said this is log base 10, so then we apply the rest. So then 10 to the first power is going to be equal to x squared minus 3x. That's really 10 equal to x squared minus 3x. We should then, it's very obvious now that we should put this in quadratic, standard form for a quadratic. So this would be subtract 10. And I'd have 0 equal to x squared minus 3x minus 10. AC, 1 and 10, 2 and 5. 2 and 5 is going to work as 1 let's see, x minus 5 and x plus 2. So that must mean that x is going to be either equal to 5 or negative 2. And this is, again, one of those things where we need to go back and check to see if these solutions are real. Okay, so if I substitute in 5, that's, and we can throw this into our calculator, that'd be log of 5 minus 3, which is 2, plus log of 5. Let's see if log of 2 plus log of 5 equals 1. So let's see, log of 2 plus log of 5. It does equal 1, so 5 does work. Let's check to see if negative 2 works, okay? So that'd be negative 2 minus 3, so that'd be log of negative 5 plus log of negative 2. Let's see if it equals 1. So log of negative 5 plus log of negative 2. You're actually going to get an error because there are no real answers. So negative 2 does not work, so 5 is our only solution. So again, be sure that if you happen to get 2 answers, check to make sure that both or any of the solutions are a solution. All right, our last one. All right, so the first thing I notice is that they have a common base of 10, but what I notice is that we have subtraction. And remember, subtraction is division. So this is going to be log of 6 over 3x equal to negative 2. Remember that this is log base 10. So here we go. If I write it in exponential form, this is going to be 10 to the negative second equals 6 over 3x. 10 to the negative second is really 1 over 100, right? Because 10 squared, 10 to the negative second is really 1 over 10 squared, which is 1 over 100. So 1 over 100 equals 6 over 3x. So then 3x is going to equal 600 if we cross multiply. And then finally we will divide by 3, and so x will equal 200. All right, guys, that is it. Remember, if you have any questions, please be sure to come see me for tutoring.